Good evening, folks. How you doing today? My name is Paul Capera. I am the Director of Parks and Recreation for Middletown Township. I appreciate so much that you guys came out on the Phillies game 2 tonight. So we promise we'll get you out of here at 8:07, or if you got to go and see the first pitch, you just know. We're thrilled to have you. I just wanted to let you know that we are recording this session, okay? So we're going to put it on our website and everything else like that. So while the speakers are going, when we go through Q&A and you see me running around like an idiot with the microphone, that's just so we can get the question on audio, okay? So that's it. I just do want to thank you so much. I want to present our speakers, introduce them real quick. So we have Kevin Deeney from our Environmental Advisory Council. We have Tom McCool, our Building Code Officer for Middletown Township. And from PICO, we have Tom Hill. How could I screw that up? Okay. So we're very thrilled. And also we have Ted Duran in the back from PICO. He's our government liaison. Okay. Without further ado, I'm going to hand it over to Kevin. So Kevin and Tom are going to co-present for about 45 minutes. You could ask questions along the way. And then Tom Hill will take it at the back end and then finish up with some questions, and hopefully everybody's leaving just before 8 o'clock, okay? If you want to stay and ask more questions, feel free. And if you got to make that first pitch, feel free. So we do thank you for coming out. Without further ado, here's Kevin and Tom.
Thank you, Paul. We're going to talk a little bit about weatherization tonight, as you are well aware. But weatherization may mean something different for different people. The term weatherization has been changing over the years. We're going to talk a little bit about what that means in terms of what the government believes it means and what we believe it means. And one of the things to keep in mind as we go through this discussion is it may seem strange to you that an Environmental Advisory Council is the one who is hosting a discussion on weatherization. We'll try to answer the question as to why. Okay. When we think of weatherization, generally, we want that focus to be on our homes, that we're intending to weatherize our homes so that they're safe, which is the highest priority, that they're comfortable, that we can live in them comfortably, which is, after safety, that's the second priority normally we have. The third priority is sustainable. We need to have these homes for a long period of time. It's the one investment we make as owners, one major investment we make as owners for most of our lives is the highest investment we're going to make. So we want that home to last for a long period of time. We want it to be sustainable. So from an asset standpoint, that's important to us. But that sustainability also has a whole nother meaning when we look beyond the individual into the community and beyond. And we'll tie that together as we go on. The number one question most people have about weatherization and spending money on your home is about spending money on your home. How much does it cost? What does it cost to me? How much is available to me as for support? And so on. There is a weatherization program that most of us are at least exposed to when we see headlines or newspaper articles or whatnot about weatherization. They tend to crop up in the wintertime when there's a snowstorm, when there's, I don't know, some unpleasant cold experience going on. Somebody's talking about weatherization, which is a little late to be talking about weatherization, but that's usually when it comes up. And typically what they're referencing is the government program that's involved in weatherization. And that government program, at least the one I'm referencing here, is funded by the Department of Energy, which might sound a little strange to you, but they fund a weatherization program out to the states, and then the state manages that program, and the county executes that program. And that program is designed to provide some support for low-income households. And the typical focus of that program is safety. You want to make sure that the heating equipment in the house is safe, that you're not generating off gases or carbon monoxide or carbon dioxide, that you're not generating mold in the house, and so on. Their focus normally starts at safety. And there's a whole program and a whole federal set of criteria to execute when you go through a program, evaluate a house, and you determine whether or not it's safe for the inhabitants. And then if that is taken care of, is it therefore functional? Is it efficient? And does it use energy efficiently? That's generally their focus. That program is available for low-income families generally. And the threshold is about 200% of the poverty level, the federal poverty level. There's another program that PICO manages that they'll talk about as well. But that's generally available for, again, low-income households. But for those of us who are not in low-income households, the IRS has some credits available to us that we can apply towards for things that we're doing to make our houses more energy efficient. If we have an audit done, and we'll talk about audits in a minute, if we're doing work on the building envelope, and the building envelope essentially is the walls, the roof, the windows, the doors, those things that essentially are the skin around the house, that envelope that we live in our homes. There's a $1,200 a year tax credit that's available, up to 30% of the money that you're spending on a project, up to a cap of $1,200 per year that's available to you for those criteria. On the right side, there's another credit that's available to you up to $2,000 a year if you're spending that on a heat pump water heater, a heat pump system, or a biomass boiler. Those credits are available to you if you're doing those things for your home to make them more energy efficient, more comfortable to live in. They have to meet certain criteria in terms of efficiency. And if you're being strategic about how you're spending money on your home, you can perhaps see that maybe you don't want to do windows and insulation in the same fiscal year. Because if you do windows one year, it could be a $1,200 tax credit, and you do the insulation the next year, that could be another $1,200 tax credit, and so on. Now, these things are subject to having your accountant look at it, your tax provider look at it, but throughout this presentation, you'll see links up here in the slides that if you click on that link, and you'll all have access to these slides that you can download from the township website. But you click on that, that will take you to the IRS information about what's available for the tax credit.
Building envelope is windows, doors, what's property?
The question is, what is the property that's listed here? I'm not quite sure what it all entails, but one of the things that comes to mind is the smart thermostats. It doesn't follow the normal course of the definition here of an envelope or an audit, but it's property. It's something that you can buy, which is a piece of equipment that adds to the efficiency of way the house is managed. So there may well be other things in that list of property as well. Okay, so that's available up to a maximum of $3,200 a year. And if you're being strategic about it, spread it over a couple different years, that seems like something you want to consider. There's another tax credit that's available to you for residential clean energy credit, also through the IRS, and it comes off your, it's essentially a tax credit. As you can see, that tax credit is available to you for the years 2022 to 2032. And then 2033, 2034, at the end of 2034, it ends. And that is for specific things.
Consider part of
The question is that additional to the other one? And that's yes, as far as I understand it. This is, as you can see, there's a specific time range that these credits are available to you. They end in 2034. These are bigger ticket items, and it's up to 30% for the first stage of the project cost, and then it steps down to 26% as a rebate, and then 22%, and then it ends. So that's available to you.
I noticed for the solar, wind, and stuff like that, it's a 30% credit, but on the right it says fuel cells, battery storage, and in parentheses it says 2023. So is the 30% credit for battery storage only for this year, or does that extend out to?
That's when it
2032?
started. The battery credit came in the year 2023, so that will continue to run. So as an example, you put solar power system in your house. It's $30,000 project, let's say. That will translate to a $9,000 credit. Right? You're eligible for 30% of that project cost coming back as a tax rebate. Now, this is my look at this. I've made advantage of that. I've taken advantage of that myself in my own house. There may be a lot of other nuances that are available strategically for how you would approach this as well. Go to the IRS website, and there's a lot more detail there. They'll explain the process and how to submit for the rebate. Pretty straightforward process, but it can be a big chunk of money. Now, one of the things to keep in mind, particularly because this is being given in Middletown Township, there are some local things that are important to us as residents for this whole region. And one of the things to keep in mind is the houses we live in right now. In the 1970s, there are some people in here with white hair like mine. You can remember the first energy crisis we went through, right? When everybody turned off the spigot to oil and we all went crazy, and we had the odd and even days of filling up our cars and all that craziness that we went through. Well, that period of time triggered energy code development. And prior to the 70s, the 1970s, wasn't a great deal of specific information about how to save energy, particularly how we save energy in our homes. From a design standpoint in the past, we can solve almost any problem if we throw enough energy at it. So all it takes is more horsepower. And I could put a bigger motor, I can run a fan longer, I can do whatever it is. As an engineer, I can design something that can get that job done. You may not be able to live with that design, but it'll cool the house. It doesn't Doesn't matter to me if half that air is blowing out the window, but I can make that heater big enough to heat that air and keep it comfortable. Well, at that point in time, that began to matter. And it began to matter to all of us. How efficiently we use the energy in our homes became really important. And that generated, after the 1970s, some impetus to improve our building codes so that we can design to a set of codes that make our houses more comfortable. They're certainly safe, more comfortable, and more sustainable going forward. So, given that, where are we in this township? Where are we really in all the surrounding townships? But my focus today is on Middletown Township, because that's where we're standing. If you look at that chart, that pie chart, and this is census data that's available to everybody. Believe it or not, the government does a lot of survey information in the years they're not taking census. They're doing a lot of surveys too. And they're surveying, some of the things they survey is the age of the home. What year was that property deeded? When did that house go into service? And that becomes important because the codes that existed at the time helped to define how efficient we think those homes are. And if you look at that distribution from the data from 2021, about 60% of the homes in this township were built before the existence of energy codes. So the only codes that were available at the time to build were those that were essentially focused on structural and safety issues, but not so much on energy efficiency. That began to develop later. So all those older homes now, it's questionable about how sustainable they will be going forward. So there's a pile of homes here that really could benefit from weatherization. And in this township, I think there's about 14,500 single-family homes, somewhere around that. In this township, like most other townships in the state, they've adopted the Uniform Construction Code. So that's the building code we all live with. But that code focuses on new construction. And that's important to keep in mind. It doesn't deal with existing homes. And if you recall the last slide, we have a lot of existing homes. So those are the ones that need the most weatherization. The new codes will help us going forward, but they can also act as a guide if we choose to weatherize our homes as to what we would like to achieve. Can we achieve those new construction standards or come close to them and develop an efficient, comfortable, safe house to live in? The first step of the process is to start with a plan. And this process I've gone through. So I'm not telling you anything I haven't already done. So for me, this isn't theoretical. You start with a plan. And that becomes important because you don't want to do a lot of things to your house that you have to undo later. And some of these things are sequential. And we'll talk about that. And you need to establish some priorities. So what are you going to do first? One of the very first things you want to do is do an audit. You want to assess the house. You want to assess the property. And when you start looking into the audit process, there are a couple of terms you'll see a lot. The word audit is used and the word assessment is used. And they're used interchangeably by a lot of people. I have found that when audit is used, it's really a kind of a high-level examination of your house, where somebody will ask you how much energy you're using, do a walkthrough of your house, poke into a couple different areas, and look at a lot of the conditions of your house without getting too deep into the nitty-gritty and dirt under your fingernails kind of assessment. And then the assessment takes that to another level. So because these terms are used interchangeably, when you start the process and you do an audit, ask what the auditor is going to do in terms of the task, and we'll look at some of those tasks that are available to you. But ask the question. You're the customer. If you want an audit done, you want to know what it's going to deliver to you, right? This particular, if I can get to this, we'll see. All of these slides that we're talking about here have a they have an active link that will take you right to that website. That happens to be a Department of Energy website, which describes to you, yeah, if you would, that describes to you what the audit process or what the assessment process would be. Now, because you can get it done by various parties, they might have a different idea of what no, that's the PDF. Just follow the link, just execute the link. That's it. We want to be able to scroll down. Again, this is from the Department of Energy, and just to let you know, the Department of Energy has tons of information on weatherization and the subjects of weatherization, so much information that you get lost in it. And that's one of the reasons why you want to do an audit. You want to start with a plan, and you want to focus on those things that matter to you. One of the things that we'll talk about is a blower door test and doing a yeah, a blower door test and doing an IR scan and so on. Up. Yeah, got to redo it. Thanks. But at the end of the audit process, you're going to get a report from somebody. And that report is going to have recommendations of what you should do. It'll focus first on the health and safety issues, and then it'll detail other items you need to deal with in terms of a plan of action. The health and safety always comes first. It's always health, it's always safety, health, environment. You have to be safe in order to protect your health. You have to be comfortable in the home you're living in. You have to deal with those things first. They'll focus on heating and combustion. If you have a furnace and you're burning oil or you're burning natural gas, if you're burning anything, they'll focus on combustion. Is it vented properly and so on? And that's where all of the code issues come into play for that kind of equipment. A lot of our homes are using number 2 fuel. A lot of the homes in the southern part of the township are using number 2 fuel. In the upper part of the township, they may be on natural gas. You want to make sure there's smoke detectors, carbon monoxide detectors, and whatnot in the house if you're burning any kind of fuel, and so on. So they'll look for those things. They should be testing your equipment to make sure it's running acceptably. That's one of the things you should look for in terms of an assessment as you look to weatherize your home. You get past those issues, and then you start dealing with those things that are more associated with the comfort level and sustainability of the house. But health and safety is first. Air sealing is a big deal. There's an estimate that most of our houses leak enough air that's equivalent to a 2x2 window open all the time, all year round. That's the loss of a lot of energy. And it's energy that you can prevent from going out the door with fairly simple things. Caulk goes a long way, and baccarat and foam and so on. It can be dirty work, it can be tedious work, but it is really helpful in terms of energy efficiency and making the house much more comfortable. And you'd want to do this kind of work, and the insulation work we'll talk about in just a minute, before you do other things, like let's say you want to upgrade your heating system, or you want to convert to a heat pump or whatever. There's a big difference between a 5-ton heat pump and a 3.5-ton heat pump in terms of what it costs you to put in. Now, as I said before, we can solve a lot of problems by just throwing more energy at it. So if we have to heat a very leaky home with a heat pump, well, it might be a 5-ton heat pump. But if that same size home has been air sealed and well insulated, new windows and those kinds of things, you might end up with a much smaller heat pump and a much more focused heating system than you would otherwise need. So you do these things first, and then you do the heating systems if you're going to upgrade those. But you start looking for gaps in a lot of different areas in the house, around all the trim, around all the doors, all the windows, in the odd places you think where the wall meets the floor, where the wall meets the ceiling. We'll see some pictures of that in a minute. And after air sealing, you want to deal with insulation. And sometimes these go hand in hand. But for me, I think it's wise to start with the attic spaces. They are easier to access, they're less intrusive. You don't have to take any drywall off, you don't have to drill holes in the wall. And it really depends on if you're married, how long you want to stay married. Because if you're going to start with the walls, and you're going to start taking down drywall and doing all that stuff in the house, you have to have some cooperation because you can't do it all very fast. You don't want to open up the whole house all at once, particularly if you want to stay married long enough. So start with the attic spaces. You're up and out of the way. You can get insulation up in the attic spaces. One of the things to keep in mind is the standard for around here is R49 is what's recommended in our attics. R49 is that much insulation, right? It's over 13 inches of insulation. So most of the ceiling that you can see, all of the joists that are running through the ceiling, if you poke your head up in the attic and you can see them, you don't have enough insulation because they're not 13 inches deep. If you see the tops of them, you need more insulation. And you'll need to follow the whole envelope of the house. Walls, doors, windows, all of them should be evaluated with respect to their insulation value. How much insulation is in the wall? How much is how the windows are insulated, how the doors are insulated, are they Energy Star rated, and so on. few specifics. How do you find air leaks? There's a device called a blower door. Essentially, that is a canvas frame that there's a blower that's installed in. It's like just a big house fan. It's a device that's used oftentimes when they do an energy assessment. And that fan will pull air out of the house and just blow it outside. But air that goes out causes other air to come in. And under the test conditions here, you can measure how much air is coming out of that house at a certain condition for the test. And there's a standard to meet. We want to see 3 air changes per hour. That means we're moving the entire amount of air in the house 3 times in the course of an hour. And it's easy to calculate, relatively speaking. You know, that's a 2,400 square foot box with an 8-foot ceiling. That's 19,200 cubic feet of air in that house. And we're allowed to move it 3 times in an hour, move it out of the house 3 times in an hour. That's a lot of air. For comparison purposes, a house fan, a fan in your bathroom will move about, I don't know, 50 CFM to 100 CFM, that's cubic feet per minute. That's almost 10 bathroom fans running continuously. But that's a good standard. That's the standard we're trying to meet. So there's a lot of air that's moving out of the house. We always want some of it to be moving out of the house. But there's a standard to meet. We can use a smoke pencil to try and identify where these leaks are coming from. So if you're running a blower door test, you're moving air out of the house, you can go around different areas of the house now and see where it's coming from. Often you're doing an infrared scan, thermographic inspection. Essentially, you're taking an IR camera and you are investigating areas of the house, and an IR camera is looking at the differences in temperatures that you can see. Now, insulation, as opposed to sealing, insulation is trying to resist the change in temperature, resist the heat flow from inside the house to outside. And in our climate area, we're designated as climate zone 4A. We're a little humid. We're in the cold mixed region of the country. And these criteria tell us that we have to have 49 inches to meet new standards, an R value of 49 for attics, and an R value of 20 for walls, if it's a 6-inch wall. Or we have to have at least 13, R13 plus R5 for continuous insulation on the outside wall for a normal 2x4 wall. That can be challenging for older homes that don't have that kind of insulation in the walls. But it really matters how that insulation performs in the wall and how you install it if you're going to go through that work of insulating a home. Tom has seen many insulation. Tom inspects a lot of the homes, the new construction, and he has seen insulation installed well and not so well.
Good evening, folks. Thanks for having us tonight. I guess just to introduce myself real quick, my name's Tom McCool. I'm the building code official for Middletown Township. And I guess what that translates to is I'm the rodeo clown for the codes for the township. The codes we follow are not Middletown codes, or not Pennsylvania codes, they're international codes. So if you go into my office, I have 500 books. Each of those books have thousands of pages because it includes everything in the United States. My job, again, as the rodeo clown, is to sort through all that and answer the question. So when the homeowner calls me up and says, how high of a step can I have? How much insulation do you require? Questions like that, I can answer them. I can also answer how high a threshold has to be on a 7-story apartment building in Chicago for handicap use. Just gives you an example of the stuff that's in the code that we have to sort through. Someday, hopefully, we'll go in the direction where Pennsylvania will have a Pennsylvania code. Probably won't be pared down to Middletown, but it'll be related to Pennsylvania, and we could make things a lot easier, more user-friendly for the public. In the meantime, that's what you pay me for, and that's what I enjoy doing. As far as insulation values go, this is my laptop. These guys brought PowerPoints. This is my redneck laptop, PowerPoint presentation. I like pictures and stick people and arrows and things like that. Some of the contractors who I meet out on the street, I'm always good for giving them a diagram, you know, with a stick person and an arrow and stuff like that, rather than 3 pages of an explanation. So I just brought this tonight just to point out some of the things that you may want to consider when you get to this point. Kevin and Tom Hill definitely give you information as far as programs, how to take advantage of them, how to save money and things like that. I'm not smart enough to do any of that. Once you get to that point, that's where I try to help you out. I work for the homeowner, I work for the taxpayer, I also work for the contractor. You know, the contractor pay your permit fees, and I try to help them through inspections, because once you take advantage of all these programs and spend your good hard-earned money, how you want to apply it. That's where the beauty of the codes come in. The codes are designed, one, for mainly safety. We want to make sure we don't make the house unhealthy. 2, we want to make sure you're not taken advantage of by a contractor, or you're just not wasting your money. You may have a misunderstanding. So that's what I do. I come out and I do some inspections. And I brought this tonight because it's a typical wall inspection. Some of the things I see, some of the things that I would be concerned about or not concerned about, because again, you're to this point, you're spending your hard-earned money. Let's not waste it. Let's not make the house unsafe or unhealthy. So we have a typical wall bay here. There's 3 different ones. 2 of them I wouldn't be able to approve. One of them I would be able to. Same materials in each of them, and the mindset is, okay, we stuffed it all in there, air can't come in, but there's a proper way to do it, because the thermal envelope is not insulation, or it's not just siding, or it's not house wrap. It's a combination of those things in the proper order, so you can take as much advantage of it as possible. If they're not in the proper order, then you're actually defeating. 1, you're wasting money. 2, you could be making something unhealthy, or something unsafe even. We're making our houses and our thermal envelopes so tight sometimes we generate a carbon monoxide problem. So there's several different codes. There's building codes, there's insulation codes, there's mechanical codes. They all kind of dovetail together, and they watch out for each other. So when we make the house so tight, the mechanical code puts his hand up and says, oh, hey, you got to watch. You're going to be sucking carbon monoxide down the chimney. So, you know, blower door tests and things like that Kevin spoke about gives us some reference point. So basically, workmanship. Workmanship matters, neatness matters in inspections and code enforcement. You know, just stuffing the insulation in seems easy enough, but we wouldn't be able to prove this one in the center, which is what we typically see, because obviously we have air gaps to sneak around the outlet. The insulation tucked behind the wiring is another place where we're losing R value. Any wiring or any gaps, we're losing R value. Insulation by itself doesn't do anything. It doesn't keep your house warm. You still need a heater. If you had a house where the power goes out and it's left too long, the pipes freeze. Well, it's insulated, but why'd the pipes freeze? Because insulation doesn't generate it. It just keeps it in. So anytime we have a gap, is just as Kevin spoke about, that adds up. You know, I don't know the engineering measurement for it. I'll just use my redneck measuring. You know, you have a hole here, it's this big, another hole over there, another gap, and by the time you get to all these gaps and all this misapplication, you have a 2-by-2-foot opening all winter long in your house, or an equivalent to. So neatness does count. So we would ask them to split the insulation there, put it in the front, put it in the back. Also, carve out this box properly so insulation gets behind it, nothing's puckered. Up in here, where the wires go in, we would make sure they're caulked at the top, one for fire spread and also for heat loss. How many outlets do we have in the second floor of our house? They all have a 1/2-inch gap at the top where cold air from the attic is coming down into that wall bay. So if you have 15 1/2-inch holes, again, there we go. We're going back up to that opening in the house. So we're looking for all that. We're making sure that this is spliced around the wire here. This is in front and behind the wire over there. This is carved out nice and neat. Another thing we run into, too much of a good thing. Too much of a good thing in insulation isn't always a good thing. We have 16-inch bays. They come in 16-inch bats. A lot of times the contractor or the homeowner, they say, well, I'm not going to trim it down nice and neat like this. I'm just going to jam it all in there. And the mindset is, okay, well, here I got a 16-inch bay with a 16-inch bat. I'm getting this much. Here I got a 16-inch bat jammed into a 10-inch bay, so I must be better. But every place you see a low spot, if you had an infrared camera on this wall, you would have air leakage any place this is recessed. So bunching this in here gives you no advantage whatsoever. Matter of fact, you're reducing it. Because again, you know, if we have an R13 insulation, for example, and we compress it down, we don't have R13 anymore. Because insulation by itself doesn't serve the purpose. It's like a lasagna. It's a combination of air and insulation. So the more we squish it down, even in little places, we lose the R value. So again, neatness counts. Another thing we run into, and I guess it's a testament to the codes as far as, you know, watching over each other and bumping into each other, and is just normal sheathing on a house. You can see there's a gap here where air can leak in. And a lot of people's first thought is, well, maybe that contractor should do a better job and scooch this up closer. But the building code says, no, you need a minimum an 1/8-inch gap here. So, okay, now we got to meet the building code first. We want to sheathe the house properly so we don't have buckling, but now we have this air leakage here. So there's different alternatives, and sometimes there's house wraps get called into play, and that would span those areas to prevent air leakage from coming in. Again, we want to keep that cold air from in the bays. That air in the bays, we want it to be stagnant, and that lasagna effect where cold air isn't coming in and intruding, but the air mixed with the fiberglass insulation is serving its purpose. House wraps, they come into play. They help with air leakage quite a bit. Another alternative that helps out with remodeling. New construction is a little bit easier. We can start from scratch and we can put whatever we want in there. But you have to get away from the mindset that you can't take advantage of new things because you have an older house. How many times do you side your house or side a wall? You can't, you know, rip all the drywall off, or you don't want to rip all the drywall off to improve your insulation, but hey, I'm taking advantage of siding my house now. Now I could introduce some complete insulation on the outside, or continuous insulation on the outside. So the code allows you to put a maximum of R5 on the outside, which is 1 inch of foam. So now we've increased our R value, in this case from R13 to R18, without tearing open the walls. So just, you know, don't get stuck in that hole where if it's not a new construction, there's nothing I can do. You can always take advantage of different things in the code and science and with the programs to improve the thermal envelope of your house. Again, this is where the code comes in, too much of a good thing. I've been on jobs where guys put 3 layers of house wrap, you know, 2 inches of foam on the outside, plastic on the inside. well, then you're starting to create a mold problem. So throwing insulation components onto a problem isn't always the best way to go. Again, that's where the code comes in. The building inspector's not this big hairy guy who just makes contractors' life miserable. We're trying to help. Not that we're smarter than anybody else, but again, we're the rodeo clowns looking at the books, checking out this technology, and passing that information on to you so you don't make mistakes to cause problems. Anyone have any particular questions while we're talking about the wall envelope? Sir.
First, here's your mic.
I was always confused about perm and condensation in the walls and things like that. I was going to plan to have 2 inches of styrofoam on the outside of the wall and then go to drive it. Drive it is the fake stucco. Your opinion about that?
ASTMA standards dictate how stucco needs to be installed, and that's probably the key, because that requires two layers of a permeable vapor barrier on the outside. So you don't, because you are going to get some kind of moisture generation just by the design of that assembly. So you'll need 2 layers, one to shed direct moisture, and also 2, if anything develops there, it needs to breathe. That would be the difference between an air barrier and a vapor barrier. Air barrier keeps air from going through. The vapor barrier has a permeability rate of 0.6 or better, according to the code, is what you would need. So that's what we would do in a review and an inspection to make sure that your assembly has the right amount of layers of vapor barrier and also the permeability of each of those. They would need to be listed and labeled on there. So, you know, that's a perfect example of you know, what the inspection and the review process might point out for you before you make a mistake. The EFA system is a good system, but it's very unforgiving. Just make sure you have the right contractors to do it, and they follow the ASTM standard, because the application or the installation changes a bit depending on the thickness of your insulation in different parts of it. So.
Tom, I was always taught that you don't use both, the house wrap and the foam on the outside of the house. Because especially with Tyvek, because Tyvek has supposed to weep the moisture out. What's your stand on that?
They've made mistakes over the years of putting, you know, house wrap and foam. Technology has come around where all house wraps aren't created equal. That's the other thing. There's different permeability ratings and things like that. So it depends on the foam. It also depends on what you have inside, because you don't want too many vapor barriers. So if that Tyvek is acting as your vapor barrier to get moisture out of the outside assembly, then you can do that. But if you have another vapor barrier, air barrier inside, then you need to take that, maybe delete that Tyvek from your assembly and just go with the foam board, because that's, again, that's the beauty of the foam board. It gives you the continuous insulation, but it also works as a barrier for the air. So again, if this is doing the job, you may not need the house wrap, or vice versa. Goes back to too much of a good thing and also wasting money. You may not need both of them. So just throwing things out. But the Tyvek concerns I haven't been running into, only for the fact is the technology has changed and made it more permeable than it used to be. Anyone else? Any other thoughts? Yes, sir.
Fiberglass. You just showed us fiberglass as insulation. What about other insulations and the problems and issues like polyurethane foam, closed cell, open cell?
Seeing a little uptick in the foams. Foams have a lot of advantage to them. And again, it's going back to dollar savings and how far you want to get into it. You know, don't want to have too much of a good thing. And again, going back to the assembly, it's not just the insulation, it's the air sealing. So we would require people to seal these gaps with caulk, like we have here to keep the air from going out. We would have sill seal at the bottom of the walls to keep air from leaking in. We've had the vapor barrier in the inside, in the insulation. The beauty with the foam, and I just happen to have some right here. The beauty of the foam is it costs you more money, but it does a lot more jobs. Obviously, you got your R value. You can put more foam in and get a higher R value. You don't have to do the caulking in the air sealing of the gaps now because you got the gaps covered. You may not have to put a vapor barrier depending on your siding or insulation on the outside because this is doing a lot more jobs. This is more expensive to put in than this, but there's maybe 3 or 4 things in this assembly in order for it to accomplish the task where here you just have one component. So foam installation is more expensive, but when you start deducting any of the other things you don't need, it pays off. It's also adds structural value to the house. That's not the purpose of it, but when the engineers do their calculations and you see these houses on the news where the entire neighborhood's leveled except one house, it's probably spray foam. That's not its purpose in life, but it does add structural value to the house. People who get their house spray foam, man, their surround sound sounds great, and the Eagles game never sounded so good. But that's a perfect example. Okay, we'll spend more money on this, but because we don't have to get these other components put in. So different applications. And some even use a hybrid just like this. I didn't have that hidden back there just for hiding purposes. Some people, they want to save money. They can't afford to spray foam the entire house. They do a hybrid version. They spray foam maybe 2 inches, and then they finish it off with maybe an R11. So again, there's options out there. Don't get tunnel vision and don't think you can't do something to improve, even if your house is old or if your project is small. If you're just doing one wall, ripping out a kitchen, ripping out a bathroom, spend some time caulking that wall, sealing it up, maybe spray foam in it, maybe increasing the insulation. But don't go so far as where you just throwing materials at it, wasting money and jamming stuff in there, and then you start causing a mold problem. But foam, I think the expense scares people off, but the performance has been really well. Sure. I have a failure inside the wall?
Yes, with the spray foam. You don't have the fire retardant sprayed on the spray foam.
Actually, I don't. Actually, it doesn't require the fire coating because it's not exposed to air. The drywall in place, again, things are in assembly. One component never stands alone. So if this is going to be covered with drywall, then the listed and labeled ratings for it doesn't make it a fire hazard. Now, some people are doing this in their attics. Rather than insulating the bedroom ceiling lid, they're spray foaming the underside of the deck. Well, then you go up in the attic, and this is all exposed. Then you would need either a formula that went in there at the beginning with that additive in there, or a secondary spray on top of it to protect it, because it is a combustible under the code, and it is kind of dangerous if it's not protected. So in this application, it is okay, because of the assuming drywall's going in. What's that? In Pennsylvania. Yep.
There you go. Thank you very much. So at this time, for the benefit of time, I want to introduce Tom Hill from Pico and let him take over for a little bit. Tom, use this mic.
Okay.
That one's been going for, or you can talk from here if you want to. Just want to make sure that's off some batteries.
Technical support, please, to the front.
So folks, while we're waiting for technical support to kick up, I'll just let you know that we are recording this. If you're registered through our website, I'll send you a link where you can find it on our website. If you just showed up because you saw it in the guide, I left the program open for a couple of days, just register, and then I'll send it to you, okay? So this way you don't have to search through our website, okay? Are we good, Tom?
Hill. I am a energy efficiency program manager at PECO. I'm just real briefly going to talk about some of the offerings we have in our energy efficiency programs. I want to first start by saying that all of the science and the techniques that the gentlemen before me spoke to are the same advantages and same techniques that we apply to our programs. There's no difference between what a WAP agency provides, what a PECO energy efficiency program provides, a federal program provides. Building science is building science, and it applies to every program that we have throughout the state. So energy assessments and free energy checkup. I manage the free energy checkup program at PECO, and that is for our low-income customers without the PECO service territory.
I'll sit there and advance your
My man, I appreciate it. All right, so energy assessments. There's two types of appointments that this program provides. We have what's called is a quick energy assessment, which is a $49 fee. The value of this is really incredible. So imagine you start to see, your bills increase and you're not really sure why. You switched out all your light bulbs, right? You insulated your home. You bought all new appliances, and you really don't know where to turn. So you contact PECO, you schedule an energy assessment for $49, and you have a BPI certified technician come to your home to take a look at your appliances, take a look at your HVAC system, talk to you about what's being used in your home. They look over your bill with you, not only just to take a look at the cost, but take a look at your energy consumption. I really try to hone in on what potentially could be increasing your home's energy usage. And sometimes it's things as simple as, your computers are staying on all night. We have children who play game systems all day, and they don't shut their TVs off, right? The things that use the majority of energy 20 years ago are not the things that use the majority of our energy anymore, right? We always thought it was light bulbs, right? So now we switched out light bulbs from incandescent to LED lighting. Lighting is really not the problem anymore. Our refrigerators used to use a ton of energy 20, 30 years ago. It's really not the case so much anymore. Washer and dryers still use a lot of energy, and that's what they try to hone in on is, how many loads of laundry are you doing per week, right? Who's using what in the home? What is your thermostat set to? Really to try and find things that you could do yourself that help you save some energy, save some money on your bill. What's included in the cost of that is a detailed report of the advisor's findings, give you some recommendations, and also what's included in that is free direct installation measures. So again, if you have incandescent light bulbs that haven't been changed out, then you'll swap those out for free for you. Energy saving smart strips. So we have smart strips that will actually shut electronics off that are not in use. That's all free. And if you happen to have electric resistance water heaters, you can actually receive aerators and shower heads and pipe wrap free, no cost. They also offer a $99 assessment. And what's included in that is, if you take a look at the photo, is thermal imaging and blower door diagnostics. I really can't express how wonderful it is to experience a blower door test in live action, to have the technician throw that fan on, and all of a sudden you feel cold air on the back of your neck. Whoa, where's that coming from? And really, it's really, sometimes it's simple, sometimes it's hard to identify. But again, what that technician is going to be doing is running that test and walking around your home and trying to identify where the air leakage is occurring. So, you know what? Your problem is in your attic, or your problem is in your basement, or Your problem is your outlets. Your outlets aren't sealed correctly. So they try to zero in on what's causing the problem in your home, what's driving up your energy consumption. So at the completion of that assessment, which is $99, again, the value, imagine your energy bill is $300 a month. You're like, I really just need to figure this out because I can't afford these bills. And the value of $99 to have someone come to your home to diagnose your entire house that would potentially save you thousands over the course of your lifetime is immeasurable. So it's $99, but it can potentially save you thousands. So you look at it that way. So again, the advisor will find out things that you potentially, steps you may need to take to save energy. You need insulation in the attic. You need to air seal the attic. You need new windows. You need to caulk the windows. You maybe just need a door sweep on the bottom of your door. The advisor will make these recommendations and also make recommendations to subcontractors that work with our programs that will come install these measures for you for free. And also show you these measures and the rebates that you can receive by going ahead and moving forward with some of the measures and recommendations. And I can't overstate the importance of these gentlemen mentioned, health and safety, right? That's the first step. You can't air seal your home without knowing that there's some type of moisture problem in your home, or you potentially have a carbon monoxide problem in your home that would lead to. So health and safety is always step one. We don't want to do anything in your home that would create some type of problem for you moving forward after air sealing and insulation is be added. It's what's best for you, what's best for the home, but they'll also make a recommendation. Say, hey, you know what, I was in your basement, a lot of moisture, I see water on the walls, I see water wicking, through the center block of your home. These are steps that you need to take first before you can air seal and insulate. And that there's a lot of value in that, and it's very important. That's always step one. So again, recommendations, measures that we can provide for you from a utility, a list of subcontractors that work in your area, as well as the rebates that we offer throughout for the utility. Next slide. Free energy checkup. This is a program that I manage. So again, we offer the same two types of services. We offer a free energy checkup and a free energy checkup plus. The free energy checkup plus appointment is for PECO residential customers who heat with PECO Electric. So if you have electric resistant baseboard, or if you have a heat pump, or God forbid you have an electric furnace, which may be the worst thing you could ever have in your home, we'll come out and try to identify ways that we can save you money. So in order to be eligible for my program, you have to be at 150% of the federal poverty level. And with my slide, it actually outlines what that looks like in terms of household income based on the number of occupants in your home. So again, we'll have an advisor come to your home to try and identify things that you may be doing yourself that are causing your bill to go up. It's always TVs. It's always the kids leaving TVs on at night. It's electric space heaters in areas of your home that are chilly. Some people put the electric space heater in the bathroom because their bathroom is always cold when they close the door. Electric space heaters are always a primary reason why we see people's electric bill creep up in the wintertime. All of the treatments, the light bulbs, aerators, smart strips, HVAC systems. So if you're a customer who's eligible for my program, let's say you have electric resistant baseboards. Again, highly inefficient, no real way to control the temperatures coming out of those things. We'll actually displace those with ductless mini splits. We'll insulate your home, air seal your home, all at no cost. So if you have someone you think might be eligible for a program like this, please, step one, actually see if they qualify for PECO's CAT PIP program. So if you're at 150% of the federal poverty level, you may actually qualify to receive a reduced bill based on your electric usage. So have someone apply, call the PECO call center, see if you can get that credit. There's also a lot of low-income programs throughout the state. There's LIHEAP, where you receive heating assistance on your utility bills. There's matching energy assistance funds that can help you in terms of crisis, things of that nature. These programs are really stood up to make sure that our customers are safe, are comfortable, and their energy bills are not skyrocketing, which in the wintertime we all know is a real big problem, especially in our service territory. And again, mentioning health and safety is always a component with both type of appointments we have. So again, looking for moisture problems, looking for friable asbestos. A lot of the old homes in Philadelphia have asbestos on their pipes or asbestos insulation. Out in the counties, York County, Cheshire County have a lot of asbestos in their homes. We take a look at that. We also take a look in the basement. Do you have things, combustibles in your basement next to your heating system that should not be there? We'll take that opportunity to point out, say, hey, you really need to take care of this, get this out of here, things like that. People store a lot of cardboard in their basements, which actually gets wet, takes on moisture, and becomes moldy. So we look at your house holistically. What we do in the basement impacts what we do in the attic. So house is a system approach. What we do here is going to affect over there. So it's very important to have someone who's certified and trained in building science to come to your home to make recommendations for you. Next slide. We also have PICO rebates in Marketplace. So if you are looking to, again, upgrade your heating system, you're looking to have insulation installed, if you want a new fancy heat pump water heater installed in your home, PICO actually offers rebates for all these products. You can actually, a lot of times if you have a HVAC contractor come to your home, installs one for you, they actually are well aware of the rebates that we offer in the PICO service territory. We actually meet with subcontractors throughout the state on a regular basis, let them know about our programs and the rebates that we offer on a regular basis. Maybe you're just, sure. So typically, your contractor who installed them should make you aware if that model is eligible for a rebate. Not if it's through the state or a tax credit or through the utility. What I would say is get the model number. You can go to our website and we'll have a listing of all products that would be eligible for a rebate. So again, once they provide the slides after the meeting, I'll definitely go to our website to see if that model is eligible for a rebate. Typically, just the receipt, certificate of installation, things like that, the subcontractor who installed the measure, and they just submit that documentation through the website. The call center rep can walk you through the process. The website is really detailed to walk you through the process to get you to rebate for the measure.
Great, thank you.
Yeah, sure. Any other questions? Sure.
Is any of this stuff retroactive for people that might have had it done 3 years
So-
ago and didn't know about this?
I want to say we go back 120 days. So if you have something installed, and sometimes there's exceptions made too. If it's like you're on that 125, 130, usually we like to take care of our customers. So great question, no. We also have a marketplace. So if you see that there's these smart thermostats out there, Nest thermostats, Honeywell smart thermostats. We actually do instant rebates on PICO Marketplace. You can buy a smart thermostat, dehumidifiers, air purifiers. We actually offer, you can actually, light bulbs, smart strips, a lot of products that are on our marketplace that apply instant discounts at the point of purchase. It'll help you save energy, save money. The one thing that's also worth mentioning for the energy assessments program and the free energy checkup program is that we just don't have these things installed for you and walk away. There's a quality assurance component to this too. So after these measures are installed, we have a certified quality control analyst come to your home to make sure these things were installed to code, they're working effectively and accurately to make sure that you're satisfied with the products, especially if you paid for them, but also if you've received them free as part of a program. We want to make sure that what you're getting is energy efficient, working, and you're happy with the product as well. It's a real big piece to what we're doing as well. So again, if there are any questions, the links to the websites are attached to the slides. I will also leave some of my cards along. And if you have any questions, please feel reach out to me. One other thing I want to mention too, real briefly, we also have a multifamily program. So if there's any multifamily developers, management out there, we do free in-unit assessments for both market rate and income eligible. Doesn't matter if you're master metered or individually metered customers. We'll come to your home and provide these services to you at no cost whatsoever. So if you live in a multifamily building, we still got you. If you're a renter in a single-family home, we're still able to provide these services to you as well. No cost to your landlord or owner of the property. Some instances, we just require a landlord consent form to receive some of these upgrades with our programs. Sure.
You're talking about dehumidifiers. How about when you have humidifying installed on your heating unit for the wintertime? Is any of that covered in that, like April air systems? Or?
Right, right. As far as I know, there's no rebates that I'm aware of for, inline dehumidification. Right now, we just have the individual units. I will say one of the things we're working on now is adding ERVs and HERVs into our program. That may be adapted into a direct install opportunity, but also potentially a rebated product at some point in the future. Sure, understood, yeah. Yep. All right, no question? Thank you very much, appreciate it. Thanks for driving.
Kevin, do you want to wrap it up, or you're all good? Have a hand for Nick, everybody.
As I said at the beginning, it's unusual to have an environmental group having a discussion about weatherization. And you can see from, I guess, a lot of the discussions here that there's a great deal of energy that we expend in our homes. And energy is a big deal. Not only do we expend it, but we have to create the energy somehow. And the creation of that energy has issues for us as a community, as a country, as a planet. What you see here are downloads from NASA as of a week and a half ago. The top left are the CO2 concentrations in the atmosphere. That yellow line is moving up at a very quick pace. The graph below it is methane, also moving up at a very quick pace. And the graph on the right is temperature of the planet, the atmosphere, the planet. We know, and one of the things as an environmental group, as a township, they've passed a climate action plan. And they're in the process of executing that plan, which is to do what they can as a township to try and reduce the amount of emissions that are generating CO2 and methane and whatever. So that will involve in the future a conversion of their fleet vehicles. You'll see solar panels showing up on top of rooftops in the township and so on their municipal buildings. But often when we see these graphs as individuals, and you can see that these are moving steeply up. We've all had discussions about, the fires in Canada and in the West and the storm effects that we've lived through lately. We know that all of our school buildings around here were originally designed without air conditioners, and now there's no way we could live without them, also in our homes. All things are changing. And we have a tendency to think that, okay, this is the new normal. If you look at these graphs, we have no idea where the new normal is. These things are moving up at such a steep slope, we haven't turned the corner. So we don't know where new normal is yet. And in the face of this, we often ask ourselves, what can I do? It's just me. What can I do? These are the things that we've been talking about tonight that we can do. We own houses, we live in houses. It takes energy to run those houses. And weatherization is a big deal. The two biggest users of energy on the planet is transportation and what we use to power and heat our buildings, commercial and residential. We have control over some degree of that in how we live and how we manage our homes. And this information helps us manage that in a way that's empowered. You're not going to do it in a minute, but you can take the steps and work the plan. And that's why there's an environmental group hosting a discussion on weatherization. Thank you.